In the previous lesson, we learned how to use the stoichiometry converting from mass to mole, or from mole to represented particles, or from mole to volume in terms of liter. Now we are going to look at how do we convert from moles A to moles B. And what we are going to focus on is this part of this conversion factor. And we are going to look at chemical formula. By looking at the chemical formula, we can actually look at the mole ratio between different substance or different part that make up a chemical formula of that particular substance. For example, let's look at this. How many moles of hydrogen are in 2.1 moles of hydronium ion, which is H3O+. So I know for sure that in here we would have hydrogen, and hydrogen is represented by the letter H. And the question asks us how many mole, so question mark, mole of hydrogen. This is what we are looking for, okay? And we are given, and how do you know if it's a given? It is the starting clue that is given to us so that we can solve for what we are looking for. And we are given 2.1 mole of this particular substance, H3O+. Now the same setup that we had before, right? We're going to start writing down what are we looking for, question mark mole. So that way we can double check our answer. It's question mark mole of hydrogen. And then we use our given. As always, we always start from our given. In this case is 2.1 mole of hydronium ion, which is H3O+. And we know right away, now we have the letter A and the letter B. I always use the letter A as the chemical of the given, okay? And this is the chemical of the unknown. So in this case, I'm going to have this as my letter A, and I'm going to have hydrogen as my letter B, just to make sure it is consistent throughout the year. So I'm going to multiply from mole. See, I'm starting from my mole of one substance to my mole of another substance. And that is going from here to there. So I have to multiply this conversion factors. In this case, this is where I'm going to start, and this is where I'm going to end. So to get from mole A to mole B, I just need to multiply by this conversion factor, which is the number of moles A equal to the number of moles B. There you go. And notice all I have to do now is substitute in what is A and B. Well, I know that A is my given chemical, so I can substitute that in, so which is H3O+. And what about my B? And my B in this case is the chemical of the unknown, which is H, or hydrogen. Now, how do I get these values right here? These values are either coming from the coefficient or the subscript. But we are dealing with chemical formula. We are looking at the subscript, okay? Now, if we look at the chemical formula of the whole entire substance, which is H3O+, we realize that in here, in this 1 mole of this one right here, there are 3 hydrogen, so we can put this here. So this is now 3 mole. And when we make a ratio, we just like to compare it in terms of 1 mole of the substance. That's why the coefficient doesn't exist there. So this right here is usually 1, okay? So in this case, we have our conversion factor set up in terms of a flowchart. Now let's rewrite this as fraction and simplify. Again, starting with our given, 2.1 mole of H3O+ time this conversion factor, which consists of 2 measurement, moles of B and moles of A. So we have moles of H3O+, and this down here has to be exactly the same as this one right here. So it has exactly the same unit and chemical. So look at this. Here we have moles of 3 moles of hydrogen, and we have 1 mole of H3O+. So this must be down here. So we have 1 mole of H3O+, and up here must be the top part right here. So we have 3 moles of hydrogen. Look what happened. this cancels each other out and giving us our answer in moles of hydrogen, which is exactly what we're looking for. And 2.1 times 3 moles of hydrogen give us 6.3 moles of hydrogen. This is exactly what we're looking for over here, isn't it? So this question mark now, we can replace that with 6.3. And that is how you solve using the mole ratio to find how many mole of a specific chemicals are part in a substance. Let's try another problem. How many moles of nitrate ions are in 9.1 moles of calcium nitrate? And notice how we have moles and ions. Read this carefully. This is the unit, okay? And this is the type of substance that we are looking at. So sometimes we look at ions and say, hey, that must be the unit. No, read it carefully. This is the type of substance that we are looking at. So be careful with that. So in this case, we are looking for question mark mole of NO3 minus. That's the ions right there. And how many moles of NO3 ions are in 9.1 moles of this right here is your NO3 minus right here, okay? So in this case, what we have here is 9.1 mole of CaNO3 2. There you go. So let's go back to our flow chart again. And notice how we are starting from a given with one chemical and we're going to convert to another chemical. So, of course, I'm going to start here on my flow chart. And I'm going to end at moles. So mole start with end with mole. In this case, this is where I'm going to end. And to get to from moles of A to moles of B, as always, we always use this as our A, which is the chemical of the given, and B is our chemical of the unknown. So we're going to multiply that. So again, rewrite with, what are we looking for? Mole of NO3 minus. And we are given 9.1 moles of calcium nitrate. And for mole A, which is right here, are given, we're going to multiply that conversion factor, just like we did before. In this case, number of mole A equal to the number of mole B. Now I'm going to go back and substitute in what I know about this conversion factor. Well, I know A is the chemical of the given, which in this case CaNO3 parenthesis 2. And my B is the chemical of the unknown, which in this case is NO3 minus. Okay? And what about the number of moles on both sides? So let's go back. Can we figure out a conversion factor given from our information? We know that calcium nitrate has nitrate in it. So let's rewrite this. CaNO3 2. Can we write a ratio based on this? And of course, we are looking at the subscript when it comes to chemical formula. Okay? So in this case, look at the nitrate, which is right here. And that 2 right there indicate there are 2 moles of nitrate. So this is 2. Well, do we have anything in here? No. If there's nothing there, we'll put a 1 right there. So again, when we work with chemical formula and looking for part of a chemical formula, we always assume it's going to be a 1. Because it's easy to compare everything to one substance rather than multiple substance. The math is a lot more easy. So therefore, this one must be 1. And that's all we have to do. Now let's simplify this, okay? Now let's rewrite this and cancel out our unit and chemical to get our moles of nitrate. Well, one thing I noticed, a lot of students ignore and they did not copy this part right here. They did not annotate the question. And that's the reason why they struggle, because they don't know what's going on, because they're too focused on just writing the minimum and getting the answer. So now, if we have this, you understand how things actually work in terms of canceling out unit and multiplying the right conversion factors. So we have 9.1 mole of CaNO3 2 times the conversion factor. Now we can see that how this is being used as a fraction. This moles of calcium nitrate has to be the same thing as down here. So we'll look at our conversion factor. Which one has moles of calcium nitrate, which is this part right here. So we have 1 mole of calcium nitrate So by taking the time to write this, now you understand how they work together. In this case, if this is on the bottom, this part must be on top. So you have 2 mole of NO3 minus. And then from there, the moles of calcium nitrate cancel each other out. Now do you see it? You've given us 9.1 times 2 moles of nitrate, which is exactly what we're looking for. And this turned out to be 18.2 mole of NO3 minus, which is exactly what we're looking for over here. So this can be replaced with 18.2. So again, take the time to write down everything. It helps a lot when you study for your tests. Now let's try to look at a more complicated substance, which usually is a hydrate. And what is a hydrate? A hydrate is basically a compound where usually ionic compound has water molecules surrounding it. And what is a hydrate? A hydrate is basically an ionic compound, which in this case is your MgSO4, okay, surrounded by a fixed number of water molecules. In this case, 5 water molecules, and that's basically a hydrate. And this problem has increased in its rigor because of the complexity of the chemical formula. But the approach to solve this is very similar. How many moles of water are in 3.1 moles of magnesium sulfate pentahydrate? And of course, on a computer, we use the format, use a period to represent a dot. That is a dot. That dot is basically represent multiplication, okay? But we don't want to use the letter X. We're going to use a period to represent a dot in the chemical formula of a hydrate when we type in our answer. So let's go back to the problem. Well, we are looking for moles of water. In this case, this is moles of H2O. And then we are given, okay, as our given right here, we have 3.1 moles of magnesium sulfate pentahydrate. So we have a given 3.1 mole. And again, we're starting with the unit moles of A. Always start on size A, okay? And in this case, MgSO4, 5H2O. There you go. Now, let's go back and look at a flowchart. Of course, we're starting from moles of one chemical to moles of a different chemical. And this is the only place that's fit. So we are going to start from moles of A, and we are going to end at moles of B. And to get from mole of A to moles of B, we multiply by this conversion factor. So let's start. Let's rewrite from our given. Well, we are looking for moles of water. So that way we keep in mind what are we looking for. And we are given right here 3.1 mole of magnesium sulfate pentahydrate, MgSO4, 5H2O, okay? And time, how many conversion factor from mole A to mole B? Just one conversion factor, which is equal to number of moles A equal to the number of moles B. I spaced them out because I know I had to write a lot, okay? And notice now I go back to my conversion factor and label what I already know. And I always, again, use my given chemical as the chemical A, and the chemical that I'm looking for is the chemical B if there are any changes in terms of chemical. So in this case, I label my A, which is magnesium sulfate pentahydrate. So MgSO4, 5H2O. And my B is what? Is water, okay? And how do I get the mole ratio in terms of the number right here? So this is a more tricky problem because if we look at the whole entire substance, which consists of water in it, right? We have MgSO4 times 5 mole of H2O. This is the part we're looking for. How many moles of water in the whole entire thing? And if you look at this very carefully, this coefficient determines how many of the water. Okay, in this case, so therefore, this number must be right there. So this must be 5. And of course, we always compare to the whole entire thing, which is relative to 1 mole. So this must be 1 as well. Okay, and now we are done. So again, please copy this work down because this allows you to understand how the problem works. So the easiest part is to rewrite this and simplify, which most of you copy, but you ignore this whole entire important thing. So please copy this down again, and we have 3.1 mole of MgSO4 times 5 mole of H2O. And that's our given right there. And now I just rewrite my conversion factor that I'm going to multiply by as a fraction. And again, I'm looking at the previous one, moles of magnesium sulfate pentahydrate. So down here must be the same as well. Okay, so we look at the conversion factor, and this part right here has the exact same thing as the unit and the chemical. So we have 1 mole of MgSO4 times 5 moles of H2O. And what's going to be on top? The other part must be on top, which is 5 mole of H2O. So this cancels each other out. And what is left over is 3.1 times 5. 3.5 times 5 moles of H2O, which is exactly what we're looking for, turned out to be 15.5 mole of H2O. And this is exactly what we're looking for over here, right? So right here is actually 15.5. There you go. Moles of water in 3.1 moles of magnesium sulfate pentahydrate. So don't get intimidated by the chemical formula. Always start with what's given to you and slowly analyze it and then interpret using what you know about the stoichiometry flowchart in terms of the unit and the chemical. Now let's try the last problem together. Now let's try another problem that deals with hydrate. In this case, again, this is a hydrate. And how do we know that this is a hydrate? Well, it has an ionic compound surrounded by a fixed number of water molecules. But in this case, I'm not going to look at water. I'm looking at the ionic compound part. So let's see how this is going to be different, okay? So we're looking at a question mark. How many moles of copper sulfate? So we have mole of CuSO4. And we are given 3.5 moles of copper sulfate pentahydrate. This is the whole thing. So we are given 3.5 mole of this. Okay? Now, let's go back and look at our flow chart. Of course, we're always starting from given. In this case, the unit mole is right here. And the chemical has changed from mole A to what? Mole B. So in this case, we're going from here to there. Then this is where I start. And this is where I'm going to end. So, as always, we always label our given chemicals as A. And if there's changes, we label the unknown chemical by B, just to make it that consistent. We read from left to right, okay? And let's go back and solve a problem. So from mole A to mole B, we multiply this conversion factor again. In this case, we have question mark of mole CuSO4 equal to, right? We have 3.5 mole of CuSO4 times 5 moles of H2O. And that's going to be multiplied by the conversion factor of this one here. From here to there, right? We multiply number of moles A equal to the number of moles B. And there we go. And we know exactly what A is going to be. A is the chemical of the given because it changed from A to B. So in this case, we have CuSO4 5H2O. Okay? And then for B, it's just going to be CuSO4. And let's go back and look at this. Can we figure out the number of moles of each of the part in this two measurement? So the whole entire substance is copper sulfate pentahydrate. Okay? Now before we look at water, now we are going to focus on this, right? How many of these copper sulfate are in 1 mole of this in here? 1 mole of this substance. Well, we know there isn't any coefficient here or any subscript with parenthesis. We know this has to be 1. Okay? So that tells us 1. And of course, we always compare it to 1 mole of the whole entire substance. So this is 1. So this is known as 1-to-1 ratio. Okay? And what's so special about this 1-to-1 ratio is that the chemical can eliminate or cancel each other out, but the numbers stay the same. And I'm going to prove to you right now. So we have a given 3.5 mole of copper sulfate pentahydrate time our conversion factor. And the same thing again, we look at this right here. This must be the same as that. So this right here must be what? It has to be 1 mole of copper sulfate pentahydrate. Okay? And on top must be how many? The leftover, which is 1 mole of CuSO4. And notice how we have 1 to 1, right? And guess what happened? The chemical and the unit cancel out. And what is 3.5 times 1 moles of copper sulfate? Which is 3.5 moles of copper sulfate. And that's what I meant by 1 to 1 ratio. It doesn't change in terms of the number, but it's changed the unit and the chemical. And this right here is supposed to be 3.5, which we are looking for in the first place. So learn how to use a flowchart. Please write down everything, or you're just going to give yourself a very tough time in this topic. When you write down everything, we can help you how to solve this problem very easily.